Hello friends, let us continue our discussion on various problems on source-free RL circuits, and I have taken an interesting problem here because this is going to maybe test you whatever you have learned till now. The problem might look very simple, but there are a lot of chances that you might make mistake in such questions. So let us start the question. So what is given is that the particular switch has been closed since dinosaurs walked on earth. Alright, that means the time before t equal to 0 is a very huge time. So the switch has been closed from that time and the switch is opened at t is equal to 0. That means there was sufficient time from the switch was closed, that is when dinosaurs walked on earth, till 0 minus, till the circuit has achieved its steady state condition. So they have made a little bit of comedy in the problem statement, but anyway the intention is that from the time it was switched, the switch was closed to 0 minus, it was a huge time and the circuit has already become in its steady state condition. You are asked to find the value of IL of 0 plus and V of 0 plus. Okay, so IL is given in this direction and V is given in this polarity, so please don't try to change it. Alright, so let me just make a copy of this circuit. I will require it a couple of times. Alright, so I have made the copy. So let us proceed by let us first find the value of IL 0 plus. You know that IL is the current through the inductor, therefore IL of 0 plus equal to IL of 0 minus, and that is equal to IL of 0. So let's redraw the circuit here. Let me just paste the circuit here. Alright. So at t equal to 0 minus, t is equal to 0 minus, the circuit was closed, right? So the circuit was closed, so let me just close the circuit here. So let me replace the circuit by this thing. So the circuit is closed, and now let us find the value of IL of 0 minus. Alright. So let us look what we have here. So you know that the circuit is in its steady state condition and all the inductor will act as short circuit to DC. Therefore, this particular inductor also will act as a short circuit to DC. Clearly you can see here there are a number of short circuits here. So therefore the 20 ohm will have no relevance because that is in parallel with another short circuit here, and there is another short circuit here as well. So this entire thing is another short circuit. Therefore if I redraw the circuit here, it is 2 amperes like this, and you have your 20 ohms here. Alright, and this is your inductor which has acted as a short circuit, and here is your switch which acts as a short circuit. So this is the inductor and this was your switch, and the current of IL of 0 minus is like this. So clearly you know that 20 ohm also loses its relevance because 2 amperes is parallel to the short circuit. Therefore whatever current is flowing here, it will not go through the 20 ohm, it will go like this, it will go like this, and it will go like this. Therefore clearly IL of 0 minus, which is nothing but equal to IL of 0 plus, is equal to 2 amperes. Okay, so that was the easy part of this question. Now let us take the other part of this question in which we have to find the value of V of 0 plus, in which I feel there might be a little bit of understanding required. So we have to find the value of VL of 0 plus, right? That means the switch is in its open condition. So let us replace the circuit here. The switch is in its open condition. So the switch has been in its open condition, and this current will be equal to, this is at t is equal to 0 plus, right? So IL of 0 minus equal to IL of 0 plus, therefore this IL of 0 plus will be equal to 2 amperes. I have already told you some people draw the current through the inductor as a independent current source. Alright, so let me also do that because that will provide a better clarity. It is not required, but still. Now because here you are having an open circuit, I will not draw that part. Alright, so it's something like this. So here you are having a 20 ohms, and this is only valid at t is equal to 0 plus. Please, this 2 amperes is only valid at 0 plus. So this is 2 amperes here, and this is your 20 ohms, and this is your plus or minus V. Clearly if this current was I, the voltage V of 0 plus will be equal to the current at 0 plus multiplied by 20. Alright. So our objective will be to find what is the I of 0 plus here. Alright. What is the current flowing through. Now there might be a tendency for you to think that this 2 amperes will come here. This 2 amperes has come here. Therefore these two will add and this will come here as 4 amperes. Therefore you might put the voltage V is equal to 4 into 20 is equal to 80 volts. This option will be there in the gate exam. Definitely if this question is coming to the gate exam, this option will be there. And if you mark that option, you will get a negative mark because that is the wrong answer. Another thing some people consider is that, see, this 2 amperes is coming here and this particular 2 ampere is also here. That means this 2 ampere might have gone like this. So 0 amperes is coming here. So V is equal to 0 into 20, 0 volt. This also will be there in the option. And if you put that, again you will lose mark because that is also the wrong answer. These two are the wrong answer. So what we have to do is that, let us go for the basic definition of an independent current source. Now clearly you can see that this might be a small mesh and this is also a small mesh. So if this 2 amperes is flowing like this is this 2 amperes. The 2 amperes might have flowed like this also because this 2 amperes which is here, that same 2 amperes might have come like this and is going like this, right? So if this 2 amperes is coming here, the same 2 ampere might have come here. Therefore the current which is flowing like this, the current which is flowing here is nothing but 2 ampere. Therefore V is equal to plus 2 into 20 ohm, which is equal to plus 40 volt. This will be also there in the option, and if you put this will be the correct result. This question actually tests you a lot in understanding of the engineering circuit analysis. Therefore, you have to understand the concept that whenever you are having a circuit like this, alright, whenever you are having a circuit something like this, let anything be here. This can be anything, okay, any circuit here. So if this is 2 amperes, naturally this also will be 2 amperes because it's the same current which is flowing like this here, right? Therefore if this is 2 amperes, this also will be 2 amperes. So please be very careful while approaching these questions. Please understand this question, what they are asking, so that you will not make mistakes. Now in case you don't get the idea which I have told in the previous method, you don't have to worry. Even if you use the node analysis which you know now, you can do this problem. Now let us take this particular node here. Alright, let us take this particular node and let us see what all currents are. We can see what all currents we have to consider. There is this particular current we have to consider. Alright, you can consider a current like this. Okay, you can consider a current like this, and let me consider this current, which let me call it as I of 0 plus. Right, I am calling this as current 0 plus. Now at this particular node, let me apply KCL. I am applying KCL at that node. Now this particular current, alright, that will be plus 2 amperes, right? It is leaving from the node. Therefore plus 2 I will put here. Now this particular current is nothing but this current which is coming back like this. And because that is entering the node, I can put a minus 2 here. And this IL current is nothing but 2 amperes which is also entering the node. So I'll put a minus 2. Alright. And this I of 0 plus is leaving the node. So plus I of 0 plus. And that will be equal to 0. Alright. That will be equal to 0. Therefore, this 2 and this 2 will get cancelled. And I of 0 plus will be equal to 2 amperes. And therefore, V of 0 plus will be equal to 2 into 20, which is equal to 40 volt. The same result you will get in the next question. I want you to think about this question because this actually tests your fundamentals. That is why I have put it in a small video. In case you are having doubts, the comment sections are open. So please like, share and subscribe this video, and I'll see you in the next lecture. Thank you.